Hello my dear students, welcome back to my channel. In today's video, I am going to explain everything in English because one of my students from Tamil Nadu wants an explanation only in English. That's why. Now that student is having a doubt in the topic of friction. Yes, in friction there is one statement which is given in the books and that student wants the proof for that statement. First of all, I'll show you the statement. Okay. If you read any reference book or any entrance exam related books, in that one you will easily get this statement that the minimum pulling force required to slide any block on a rough horizontal surface, that minimum force is given by this formula. Here this mu is the coefficient of static friction between the body and that horizontal surface. Okay. First of all, in pulling we need to apply a lesser force to slide the body compared to pushing. Pushing is slightly difficult, but when you pull the body the less force need to be applied. But here it is said that in the pulling also the least force that you need to apply is given by this formula. Now that student needs the proof of this formula, that how does we can prove this formula. Okay, so that's why I am going to do this. So have a look at this point carefully. Now I am going to prove this point, okay, for that student. Okay. Now to prove this point, let us take one diagram. Let's suppose here one block is there. The mass of this block is m kilograms. So on this block downward force would be mg, like this. The upward force will be normal reaction. Okay. Okay. Many times students are in a hurry. They feel that this n and mg are always equal. It's not compulsory. Sometimes n and mg are equal, but before you make such conclusion, you should show all the forces acting on a body. Before showing all the forces, never come to the conclusion that n and mg are always equal. It's not like that. Okay. Now suppose these two forces are acting on a body. Apart from that, we are applying one more force on a body this way. See, this is the applied force. Okay. This force is applied at an angle theta with respect to horizontal. See, suppose this angle, it's theta, that it makes with horizontal. See. So force is applied. This is obviously pulling force. It's like a pulling the body. It's a pulling force applied at some angle theta. Okay. Now we need to find out today the minimum value of this force only, the least value of this force. So what do you do? First of all, you resolve this force into the two components. When you resolve, this horizontal component will be f cos theta and the vertical component would be f sin theta. Right. Now if you observe f cos theta, this f cos theta is trying to slide the block. Na? So friction will act this way to oppose the f cos theta. This will be friction. Okay. Friction I am writing as just f, small f. Okay. So these are the various forces acting on a body. Now you know that this block can move horizontally, but this block cannot move vertically. So all the vertical forces must balance each other, right? So we can write n plus f sin theta must be equal and opposite to mg. N plus f sin theta is equal to mg. From this one you can get a normal reaction n. It will be mg minus f sin theta. First equation. So here I got the value of normal reaction, and see it is not equal to mg. It's mg minus f sin theta. Now this block will just slide. This block will just slide when the applied force f cos theta, it will overcome the limiting friction. Means when f cos theta become greater than or at least equal to the limiting friction. Right? When f cos theta become greater than limiting friction, obviously the body will slide. But when f cos theta become just equal to the limiting friction, that time the body will just slide. For just slide we should write equal. Okay. Okay. So when f cos theta become equal to limiting friction, the body will just start sliding. Okay. So f cos theta, all of you know that limiting friction is mu s into normal reaction. Okay. I hope you are clear with the theory of the friction. So mu s, here you put the value of normal reaction. It was mg minus f sin theta. isn't it? So when you solve this, you can get a value of f. F you can easily get. It will be mu s mg divided by cos theta plus mu sin theta. This is the value of minimum force which you need to apply. But if you observe, still we have not got the final formula which we wanted to prove. So first of all, understand this. Okay. Now this is a minimum force. From this formula, what we can conclude? We can see that this force, it's a minimum force to pull the body. It still depends on theta. If you put here the value of theta, different values of theta, if you put theta 1, theta 2, theta 3, the F will also come different, isn't it? Like this. Force still depends on what? Theta. It means that as you change this angle, the minimum force value will also change. So this force is still not constant. This force will depend on theta. For different thetas, the force value will also be different. Okay. Now out of these values, like suppose at theta 1 angle force minimum required is F1, at theta 2 angle F2 force is required, at theta 3 minimum force required is F3. Today I want to find that out of these forces, which one is the least one? Out of this also, who is minimum most? Okay. So you can understand that if you want to make F minimum, this F I wanted to make minimum. For that, the cos theta plus mu sin theta term, this term must be maximum. When this term cos theta plus mu sin theta, when this term become maximum, at that point the force will be minimum. Na? Okay. So for that, what you do? You take a derivative of this term and put the derivative equal to 0. In mathematics, you might be knowing, if your derivative of any quantity is 0, at that point that quantity is maximum. Okay. Whenever any quantity is maximum, that time its derivative is 0. Okay. Okay. It is from the maximum minimum topic of the derivative. So derivative of cos theta will be minus sin theta plus mu cos theta equals to 0. Please solve it. You will get a tan theta equals to mu. Means the theta angle which is equal to tan inverse of mu. Okay. When this angle you will keep, when the theta angle in the diagram, when theta angle will be this much, that time force will become really minimum. At minimum force will occur when theta will be tan inverse of mu. Okay. So what happens? See, in place of tan theta, we can write down mu. Okay. Or in place of mu, if I write tan theta, that time I will get a minimum force. Okay. So for minimum force, we can substitute mu as tan theta. See, this here mu is there, here also mu. We can put this as a tan theta. When the value of tan theta is equal to mu, that time force become minimum. Keep it in mind. It's cos theta plus tan theta sin theta. Like this I written. Okay. Now, tan theta you can write down as a sin theta upon cos theta, isn't it? Please write this tan theta as a sin theta by cos theta. In the denominator also you do same thing. When you do same thing in the denominator, okay, you can do it, right? You will get this expression. Yes. When you do same thing, tan theta you write down as sin upon cos. In the denominator also, then you will get this thing. This cos cancel. Sin square theta plus cos square theta is 1. So mg sin theta. It is a minimum force, least force. But what does it mean? This minimum force is mg sin theta. In this one, theta is tan inverse of mu. The theta is tan inverse of mu. So this I got minimum force, but it is still in terms of theta. Okay. This theta must be tan inverse of mu. At that time force become minimum. But I don't want the final formula in terms of theta. I want the final formula in terms of force only. Okay. So what happens? I want to remove this sin theta term. Okay. So see how to do that. See, imagine that if I make a triangle. Okay, in this I am taking the theta. It is that theta at which the force really become minimum. Okay. Now the tan of this theta is already we got it is mu s. So in this triangle here I will draw mu s and here 1. So that in this triangle, if you apply tan theta, you will get mu s. Now by Pythagoras, you will get this side as a 1 plus mu s square. Now in this triangle, if you apply sin theta will be mu s upon root of 1 plus mu s square, isn't it? Please understand, this theta that I am talking, this theta is tan inverse of mu s. It is the theta at which the force will become least. Okay, so that theta I got here. Now from tan theta, I got the value of sin theta for that angle. Sin theta is mu s upon 1 plus mu s square. If you put this value of sin theta over here, okay, then you will get a final answer, right? Mg into mu s upon root of 1 plus mu s square. So it is the least force at which the body will slide. It's a minimum pulling force required, and you have to apply this force at an angle theta, which must be strictly tan inverse of mu. Okay, so here I explained that point, this one. Okay. So I hope that girl who's having a doubt in this, it got cleared. Okay. Remember, this minimum force needs to be applied at a particular angle. Okay, as you change the angle, this minimum force will change, and the angle at which the force really become minimum, that angle is tan inverse of mu s. Okay, so I hope your doubt is clear. Okay, in the next video we'll meet with some other doubts. Okay, till then, take care of yourself.